All right, so here we have Piotr Solnica with another awesome talk.
Thank you. I hope you can hear me fine. So the topic of my talk is Beyond the ORM, an introduction to DataMapper 2. Why beyond the ORM? Because actually we are building something more than just an ORM. And Dan Cobb, the lead developer of the DataMapper project, calls it as an ORM toolkit. You can actually take the pieces and build something custom. So hence the title. Quickly about me, I'm Piotr Solnica, another Piotr. Sorry about that. It's getting pretty boring. I'm a software developer. I work at a small company from Bend in Oregon called Benders. We have awesome guys like Avdi Grimm and Dan Cobb in the team, so if you're looking for pretty good Ruby developers, feel free to contact us. I blog at solnic.eu. On GitHub, I'm Solnic, and on Twitter, I'm Solnic with these fancy underscores. So before I start talking about DataMapper, I actually want to give you some kind of a theoretical background so that you kind of understand our motivation behind working hard on DataMapper implementation in Ruby. So let's start with active record as the pattern, which is described by Martin Fowler. And he writes that active record is an object that wraps a row in a database table or view, encapsulates the database access, and adds domain logic on the data. Now, there are two important things in this short sentence. First one encapsulates the database access. Like, it's one of the two responsibilities of an active record object. So it gives you like the access to the database. And the second thing is that it actually also implements any kind of domain logic that your application needs. This means that when you're using active record, you're supposed to have data and domain model in one thing, in one place, right? So every attempt to, for example, separate persistence from domain logic in active record is basically against the pattern. Now, in Ruby, we probably don't ask that question because every Ruby ORM implements active record pattern. So this is funny because DataMapper 1 actually implements active record pattern. Now, when you want to use a database and you're a Ruby programmer, you just use active record. This is how it is. So this is a kind of a standard thing to do. So we probably don't ask that question, we just use active record. And again, Martin Fowler suggests that active record is a good choice for domain logic that isn't too complex, such as creates, reads, updates, and deletes, which is basically CRUD, right? Now, what is a domain logic that isn't too complex? And I think that this is exactly what he writes later, that it's just a CRUD. And everything else that your application does is like domain-specific functionality of your system. And the more domain-specific functionality you have, the more complex your application becomes. And once that complexity is really, really huge, then probably active record is no longer a good choice. So this really leads to DataMapper, and we've had a lot of recent discussions in community. Like even myself, I wrote a blog post about making active record models thin, which was mentioned in one of the previous presentations here. And it's kind of funny because when I wrote this blog post, I actually really wanted to like open people's eyes so that they start thinking that maybe they should consider using a different pattern than active record. Like I suggested that you can split persistence from domain logic, but actually doing that with active record is a little bit awkward. And like recent book from Avdi Grimm, already mentioned in that conference, Objects on Rails, the solutions that Avdi suggests, everything which is there actually leads to DataMapper because we're trying to separate persistence from domain logic. And this is what DataMapper is all about. So the pattern, again, is described by Martin Fowler, surprisingly. He writes that DataMapper is a layer of mappers that moves data between objects and a database while keeping them independent of each other and the mapper itself. So again, important thing here is the separation. And when you use DataMapper, when you have your domain model, Domain model knows nothing about persistence. It actually knows nothing about the mapper even. And persistent is on one side, domain model is on the other side. And between them, you have a clean place where the mapping of data from the database happens to be. So same question as about active record previously. So when should I use DataMapper? This is probably a question that many of you can ask. So again, Martin Fowler. I should send him a bottle of scotch because I basically used half of his book here. So he writes that the primary occasion for using DataMapper is when you want the database schema and the object model to evolve independently. And this is kind of funny because he writes when you want. And it's not something that you want because it just happens. When you're, especially in case of relational databases, when you use a relational database, it's at the beginning, it's probably very similar to what you have on the domain level. But the more complex your application becomes, there's some impedance mismatch that takes place. And DataMapper is a pattern that solves that problem. So this leads to DataMapper 2. Now, as I already mentioned, DataMapper 1 is an active record implementation. And while working on DataMapper 1, we simply realized that it's a dead end. All the things that we wanted to support is just almost impossible to implement when you're using active record pattern, because the coupling between database schema and your domain model is just killing you. And at some point, it's so difficult to add anything to this library that basically we decided to abandon active record completely and focus on proper DataMapper implementation. And this is how the work on DataMapper 2 started. So it is a DataMapper implementation, and it's based on a general purpose relational algebra engine. It's going to support different data stores via adapters. This is the same concept as we have with DataMapper 1, when you basically can implement an adapter for any kind of a data store. And another interesting thing about DataMapper 2 is that it's not a single project. It's actually a collection of libraries that you can use independently. This is the only sad news. So it's work in progress. We're halfway there probably, and I'm not gonna even tell you when it's gonna be ready because I don't know. So that's the only sad thing that I have to say. So what are the new libraries? First one is Veritas. This is the already mentioned new relational algebra engine. We have also Virtus, which is a model definition and introspection layer, and Equitas, which is the new validation library, which is actually current implementation of validations extracted from DataMapper 1 and refactored and improved. And Latin names are code names, so we're going to rename all the projects when they are ready. So you have to be aware of that. We will have a new core library. Right now, DataMapper 1 also has a DM core library. Unfortunately, it's no longer tiny. There's a lot of stuff there. So the new core library will be probably much smaller. It will include the mapper, new query API, which will be a simple wrapper around the Veritas API, unit of work, and interfaces for third-party plugins, so it's easier to extend DataMapper. So quickly about Veritas. Veritas is a project that started probably 2 years ago. Dan Kapp is its author, and he's working really hard to get it ready. And what is Veritas? It's a relational algebra, kind of like RL, but it's more abstract. RL has become just an SQL generator, so it's not going to work for us because we're going to support any kind of data store, so we want something more abstract. So Veritas already supports all relational algebra operations as well as other common operations, like, for example, sorting. And really interesting thing about Veritas is that all the operations can be run in memory. So if there's a database that doesn't support, for example, joins, but you want to use that database and you want to perform joins, you will be able to do that with Veritas, like transparently. It's going to happen in memory. And Veritas can be extended with adapters to support any kind of a data store, as I already said. And this is also another concept taken from DataMapper 1. You will be able to work with multiple data stores, any kind of data store simultaneously within one application, and you will have transparent access to just any kind of a database. And it's also designed to support per database optimization. So if there's something that you can do in a better way, then you will be able to hook into Veritas and implement your own optimizer. So we can use really powerful native features of various databases. This is also one of the most important motivations behind the project, to get as much as we can from the database engine. So let me show you how you can already use Veritas. And I decided to use GitHub API as an example. So quick setup, I'm fetching a list of DataMapper organization members. Then I fetch all the commits from the mcore project, and I parse them with JSON, so I get an array of hashes. Now, to build relations with Veritas, you simply define headers, which are kind of like a schema for Veritas relations. And here I define 2 headers for members and commits. This is all the attributes that I'm interested about. And then according to the headers, I map the data to array of arrays, and each array includes attribute values in the same order like I described in the headers, right? So having that done, I can build relations with Veritas. This is as simple as that. You call Veritas relation base.new. You pass in name of the relation, you pass in header, and the tuple with the data. And a really nice thing about Veritas relations is that they implement enumerable API, so you can, for example, iterate over members or commits, and you get access to all the data inside. Now, here's an example of a restriction operation. It's an equivalent of select from members, where login equals dcup or login equals Sonic. It looks probably similar to what we have in Arrow. And the cool thing about it is that it will actually work in memory because, well, we have raw data from GitHub, right? And we want to perform restriction. You can do it. It will work in memory. And you will get proper results. And here's a join. We have 2 relations. We have members relation and commits relation, and we can join them on login and committer attributes. And it's going to just work in memory. Now, this is something really cool. Veritas has been designed in a way that you can actually perform joins between various data stores. And there's probably a lot of use cases. For example, when you have some sharding set up, you will be able to use Veritas and access your shards like transparently, just like if it was just one database, right? Also, another use case is something that I want to show you, which is using Postgres and our data from GitHub API. So Veritas already has an adapter for data objects. Data objects is a project that gives you drivers for probably all popular relational databases. So here's a simple table that we create in Postgres called users. It has 3 columns, ID, username, and country. And then we just insert some data. And now we can connect to this database via data objects adapter for Veritas. Then we define the header for our relation, just like we did in case of GitHub. And here we build a special relation that actually knows how to get data from the Postgres database. It's quite similar to what we did with GitHub, but we just use gateway here. So it's going to take stuff from the database. So as I said, it implements enumerable. So once you start iterating over the relation, it will actually issue the SQL statement and get the data from Postgres database. So now you can work with both relations from GitHub and Postgres. And you can do all sorts of operations. For example, a join, right? We can take stuff from Postgres, relation from Postgres, and join it with members relation from GitHub, and it's going to just work. Now, a more complex example, all the relations in Veritas are composable, so you can build whatever you want and combine it. And later on, you can start iterating over relation, and it will perform all the operations that are needed to get the data. And here we perform a restriction on users relation, which is a relation from Postgres. We perform a restriction. Then that restricted relation is joined with members relation from GitHub. And what's going to happen is that Veritas will actually know that it can perform the restriction on the Postgres side. So it just runs the query. So the data set from Postgres is already restricted, according to what we set up here. And then we join this result set in memory with stuff from GitHub, which I find really awesome. So this was about Veritas. You can already install Veritas. It's available as a gem. You can take a look at GitHub's README. There's a lot of examples there. It's super stable, however, not in terms of the API because it's still below 1.0, because then basically may want to change some of the public APIs. But in terms of code quality, stability, it's super stable. Like I couldn't break it. I was learning it, trying to use it, doing really crazy stuff with it, and it never broke. So quickly about Virtus. Virtus was started as an extraction of property API from DataMapper 1. Initially, I was thinking that, well, it's already awesome, so I'm going to just extract it and leave it there so we have Virtus, right? But at the end, we basically rewrite everything inside. The API is quite similar to what we have in DataMapper 1, with the exception that we renamed property to attribute. So Virtus is a library that gives you ability to define attributes on your plain Ruby objects. It also includes a coercion library, which is separated from attributes, which is also something that I refactored. It supports embedded values, and on top of that, it has support for embedded collections. And another nice feature is value objects. So quick example, here we have a user model. We include Virtus, and now we can define attributes. You get a constructor which accepts a hash with attributes, and as you can see, h is coerced from string to integer, which is kind of a basic example. And now a really cool thing about Virtus is support for embedded collections and embedded values. So if we wanted to design, for example, a library system, we can define a book class with 2 attributes, and then a library class which has an attribute books, which is a set of books. This is quite sweet API, actually. And now you can use it to build a library with books. As you can see, I pass in an array of hashes with attributes for books. And when you do that, it will coerce all these hashes to actually books instances. And it goes through the standard coercion mechanism. There's no magic inside. It's a standard thing. Now, as I mentioned, coercions are separated from attributes. I may, in the future, extract it to a separate gem. Right now, it's also part of the Virtus gem. It's a hierarchy of classes within the coercion namespace, and you can use them standalone. If you need just coercions, just feel free to use it. And here are a few simple examples. Object class in coercion is like the default behavior for coercions. And then we have a collection of all different classes that know better how to do things. If you're interested, you can just check out the sources. There's a whole list fully documented. So missing pieces. Initially, I wanted to describe the mapper and unit of work, but it's a work in progress, and I've got only 30 minutes. So I decided to drop all the details. So I'm going to just quickly mention it. So missing pieces, first one is the mapper. I started a code spike where I already implemented elements of the mapper. The way it's going to work is that thanks to Ruby, which is quite flexible language, we will be able to generate mappers on the fly, like reflect on the database schema or your model definitions so that we can build them automatically so that you won't have to write anything, which will be pretty awesome for like prototyping and starting quickly. But then you will be able to write your custom mappers where you will be able to do anything you want. So that was the first thing. And the second thing, a session, unit of work. This will be something completely new in terms of the way you work with saving data and performing any kind of changes in your database. Because with Active Record, you are using your objects directly to make changes in the database. In DataMapper, you use session, and the session is responsible for commenting all the changes that you made to your business objects. And also, the session knows the order in which the changes should be committed. This is a pretty tough problem to solve. I don't know any Ruby ORM that does that in a good way. I still find bugs in Active Record. I still find bugs in DataMapper 1. Hence, we decided to go with DataMapper pattern, which has specialized object, which takes care of this complex logic. So another thing is database schema reflection and migrations. Constraints. This is also a concept from DataMapper 1 that we really want to use database features. So if there are constraints in the database that you can use, we want to use them. Not just rely on the Ruby code, but also on the database engine. And of course, Veritas adapters. Right now, we just have a Veritas adapter for relational databases for data objects. The SQL generator is based on Postgres. It's been tested with Postgres because Postgres is the most standard compliant RDBMS system, so it was easier to use it as the first testing database. So here's an example of the mapper. This is a code spike under my account. It already works. You have a plain user class, plain Ruby object with just a constructor, and then you can define a mapper and tells it to map certain attributes to some attributes on the on the database side. And also, the query API will be a part of the mapper, so you won't be using your domain classes. You will be using mapper classes to find data, to fetch data. OK, so session is going to completely change the way you make changes to the data, because as you can see, you will use explicitly session object to perform, for example, an insert. The same goes with delete or update. The session will receive a domain model, domain object, and it will then, once you call commit or whatever it's going to be called, then it will calculate the dependencies, figure out what's the order in which it has to perform all the changes, and it's going to commit at the end. And you also will be able to use a rollback mechanism. So it's completely different from what you are used to when using Active Record. Yeah, so if you're interested in the development of DataMapper 2, you definitely want to follow Veritas project, Virtus, Equitas, and take a look at our roadmap. And I made it. Yeah. We have time for questions.
We have 5 more minutes. Any questions?
So what's the DataMapper 2 approach to transactions? Since you can join tables in memory from Postgres, so how do you handle that?
Transactions?
Yeah.
Transactions will be handled on the session side. So if your database supports transactions, then we will use it.
Yeah, but what if you join 2 different data stores? Do you get an exception that says, look catch you're trying to do something wrong here, or?
Yeah, it's going to be handled one way or the other. Yeah, we definitely want to handle that. But I don't have a specific answer right now.
It's certainly great effort, but don't you feel that this relational algebra terminology will imply that it does not support other backends than relational database? I was looking at DataMapper some time ago, and just by the cursory look, I thought it does not support other backends than relational databases just because of this terminology from relational algebra. So,
relational algebra is actually pretty nice concept. When you're working with data, it's really, something convenient. And relational algebra in Veritas is implemented in a way that you can use it with anything, but it doesn't force you to, use relational specific methods. So.
Yeah, I just feel from the marketing standpoint.
Marketing standpoint.
Yeah.
I need to cut my hair, probably.
Okay.
I have a question about features that are only designed in databases, like SQL.
Yeah.
Because not everything is covered with simple comparisons, but some subqueries or grouping or stuff like that. How will you handle that?
This will be definitely handled by the adapters. So if there's anything specific on the database side, it's going to be implemented on the Veritas adapter part, as well as the optimizer. So.
Okay, but this doesn't really say anything. How do you handle that on API level? So how do you say that you want a select subquery that would map to something in SQL, but it doesn't work with another store like GitHub or?
Oh yeah, sorry. Okay, gotcha. If you're doing something that's not supported at all, it's going to happen in memory. So if you're performing a join on GitHub data, just like I showed you, it's going to be performed in memory. So like it's hidden. Does this answer your question?
Not really, but I would get.
Okay, we can talk later. Yeah.
How would you compare DataMapper to relational?
I wouldn't, because I haven't used SQL Alchemy. I only know that Dan, when he looked at the code base, he said that there are a lot of really nice concepts, but I can't say anything more about it. I'm sorry, I just haven't used it.
What's your idea? I would like to go back to the marketing.
Okay.
What's your idea of selling it? Because active record is really simple. It makes it great. It's, an uneducated Ruby programmer can understand what's happening there. What's your idea of selling DataMapper, which is pretty complex idea? Yeah,
it is. It is complex, and
what's your idea on selling it in the simple way, so people would start using it, but then showing them that you can do better things with it than.
Well, some practical idea is that I can just come up with a lot of examples where active record is a big mess, and I'm not a salesperson, I'm a programmer. We can hire some salesperson.
So. I'm talking exactly the sales that gives you money, but the sales.
Yeah, I'm joking. Well, my main point with using DataMapper pattern is that active record is easy in the beginning, but once your application becomes more complex, then if entire logic, domain logic, lives in active record, then it's just impossible, to maintain, extend.
It's not a good approach, because then at some point you need to rewrite your domain logic that you already included in active record model to something better that you saw that code. But what would be great here would be an implementation, maybe, of active record sort of stuff in DataMapper that would make the rewrite part then maybe easier.
See, I should hire you as a salesperson. Well, yeah, I obviously understand the argument that DataMapper is a complex concept.
I'm not actually sure if everyone here understood what you showed, because it's not easy. We are talking relations in memory. So how did you join the GitHub API and the SQL API?
Yeah.
It's not easy.
Yeah, it's not easy. I know, and I had only 30 minutes, so I'm here for the next like 2 days, so I can explain more. Yeah, it is a complex pattern. It's actually a collection of patterns, and it's obviously difficult to understand, especially that somebody shows you things like blah 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 blah, like I did. But you know, there was no other way. So we have an idea to build an active record-ish layer on top of what we will have. So that it's easier to start using it. It's going to work like Active Record if we do it. But yeah, I understand that it's a complex subject.
Right, guys.
Hard to sell.
If you want to talk more, there's always the possibility that you can continue the discussion in the open space. So feel free to use that opportunity. So thank you very much, Piotr.